Welcome back, Matt Lewis. So this was the interesting challenge that I had posted 2 days back. So people who had made progress in this, so you would have felt the eureka moments. So there are two rectangles with integer sides, such that perimeter of rectangle P is equal to area of rectangle Q. So, so altogether we understand. So there are two rectangles. There are like four variables here. According to the question, the conditions is perimeter of rectangle P. I'll call this as rectangle P and call this as rectangle Q. Perimeter of rectangle P. So 2 times A plus B should be equal to area of rectangle Q. So equal to CD. Similarly, perimeter of rectangle Q 2 times C plus D should be equal to area of rectangle P, that will be equal to AB. Now you understand there are four variables in this, and number of equations is also only two. We can keep working with these two equations. Like generally in these kind of questions, students would try experimenting by adding the equations, subtracting, multiplying, dividing. But one simple rule across all this kind of Olympiad challenges where there are many variables and limited equations is try to push things towards product forms. Okay, remember it. It's like math act. Product forms will be more useful than addition forms. Product forms is a must in our equations than addition forms. And second thing is try to bound at least one variable. Bound at least one variable. So these things will surely help us make good progress. As I said, product forms are much better. So I understand here I can just multiply these two equations because there's already some multiplication happening on the right side. I multiply these two equations. I'll be getting 4 times A plus B into C plus D is equal to ABCD. Okay. So that was helping me to think of product forms. But the question doesn't end here because I said like you need to be good enough to bound the variables. So this is what we call it as general inequality because we do not know the value of these variables, but we can generally assume some inequality amongst them. See, a rectangle might be a square also, meaning A can be equal to B also, but maybe A may not be equal to B also. So it's general inequality. We can go on assuming A can be greater than or equal to B. Okay. So then don't ask, sir, why can't B be greater than A? So it's about how I took the bigger number. Suppose I see a rectangle with side lengths dimensions 5 cross 3 or 3 cross 5. I can assume 5 as my A and 3 as my B, isn't it? So that's what I'm doing. Similarly, the same thing you can apply in the second rectangle. Keep C greater than or equal to D. So they successfully imposed some inequality amongst them. So why this would be helpful? Let's see, because my right side is a good one. It's in a product form, but my left side is still in a addition form. So I'm going to ask you a very basic question here. So I have A on both sides. Okay. If you add plus A here and if you add plus B here, which side will be greater? Obviously, the first side will be having a higher chance to be greater because we know A is greater than or equal to B. When you add a thing which is greater than or equal to B, then automatically then the left side becomes highest chance of being greater. So it will become A plus A greater than or equal to A plus B. So I can read it 2A is greater than or equal to A plus B. So similarly, what we can write now, we'll talk about C plus D. I'll start with C both sides. They are equal things. Now I know C is greater than or equal to D. So if I add plus C here and plus D here, so this will become 2C and this will become C plus D. Now you understand this becomes greater than or equal to 2C becomes greater than or equal to C plus D. So I'm going to use both these inequalities that I have generated to help myself create some bounding. Okay. So I know 4 times A plus B. So I'm going to multiply both these inequality people. So see what I'm going to get. So I am going to multiply this inequalities. So when I do that, I understand I'll be having 4 times AC being greater than or equal to A plus B into C plus D. Okay. So here I already have some expression. 4 times A plus B into C plus D is ABCD. So if I insert 4 on both sides, it'll be useful for me to replace 4 times a plus b into c plus d as a, b, c, d. So I'll replace here as a, b, c, d. So I have 16ac being greater than or equal to a, b, c, d. So now you focus. So a and c, both positive values, can be cancelled out on either sides. So from which I get 16 is greater than or equal to bd. On reverse, I can also say bd is less than or equal to 16. Okay. So now you can see we are making good progress. We are creating a bounding. So until now there was no bounding, but now we have reached some bounding. Still there are two variables here, b and d. I told you at least you need to block or like kind of regulate at least one variable. So same logic. Now b and d being two variables, I do not know the connection between them. Again, if I take the general inequality between them, I'm going to take the general inequality between b and d. What if you go with b being greater than or equal to d? Okay. So if you go in that scenario, if b being greater than or equal to d, okay. So just go for the thought. I know bd is can be maximum 16. bd can be maximum 16 being or less than that. So if I replace in this equation b as d, I'll get d into d square. Correct, no? So then automatically if bd itself maximum can reach only 16, so you will understand the one simple inequality thought here. I will multiply by d on both sides, people. Okay. So this gives me bd is greater than or equal to d square. Correct? Yeah. But I also know 16 is greater than or equal to bd. So I will insert that also here. So throughout this inequality, you can understand this form. Together, I can understand that 16 is greater than or equal to bd, bd is greater than or equal to d square. So on reverse, you can understand d square is less than or equal to 16. So, but in the question, we had an imposed condition that a, b, c, d are integers. I mean, the dimensions of the rectangles are integers. So this gives us a very clear cut that d can only take values 1, 2, 3, 4. So we put a very super bound on one of the variables. This is really going to help us. So when you write any subjective Olympiad, so when you bound at least one of the variables, when you come till this step, which means the question is already 50% over. Like say in RMO and all, if it's a 16 mark question, they give you 8 marks till this step. Okay. So now going forward, so now I need to do manipulations with the other equations. So I understood D is something which I should be focusing more on because I got a bounding for D only. So I have to take my other equations and start playing with them. So I will take equations where D was actually present. Okay. So this is an equation where D was separately being present. So I'll talk about it. So I will take that equation 2 times C plus D equal to AB. 2 times C plus D equal to AB. If I take this, I'm going to get 2C plus 2D equal to AB. So I'm getting 2C to be equal to AB minus 2D. So we're not done with this. So what I'm trying here, you can understand, I'm trying to relate the other variables in terms of D. We're not done yet. So we need to further work on this. So we got C in terms of D as well as A and B. So we need to check whether other equations can also help us with this. Okay. So if I'm going back to the equation that I have created earlier, so to check whether it can help me, I have got 2C on my left side. So I have a C here, again getting multiplied with D. So in case if I can bring that same in that previous equation, I'll be able to relate to A plus B as well. So let's try and do that. So here I have 2C equal to, so I'll write that equation for you here. We had that equation as 2 times A plus B equal to CD. Here I have C alone. So what if I multiply by D on both sides of the equation? I'll be having 2CD equal to ABD minus 2D square. Okay, we're not done yet. I can substitute the value of CD. CD value is 2 times A plus B. So this creates 4 times A plus B is equal to ABD minus 2D square. Now we can understand we have been little successful here because from a 4 variable system, we already have a bounding for D and we have lost variable C here. Okay. But if you can recall the first math act which I taught you, more than the addition forms and all, like product forms is much better to uh, put equations, regulate the equations to get our answer. So still there is an addition form still involved here. Let's see whether we can do anything with this. I have ABD minus 4A minus 4B minus 2D square equal to 0. So if we take all the terms to the right side, this is what I'm getting. So, but if I can see there are now four terms, there is something common between the first two terms, which is nothing but A. If I take A common, I'll get BD minus 4. But in this 2, there's nothing common as such except minus 2 I can take common. I'll be having 2B plus D square. So this is not helping. So this is not completing my factorizing form, people. So I should understand, I should bring in something so that I'll get some common factor form. So let's see what can help us. So as we already know, D is what is more comfortable with us. So why not multiply this equation by D? Okay, multiply this entire equation by D. Let's see whether it helps. It's like a trial and error only. So it will become ABD square minus 4AD minus 4BD minus 2D cube equal to 0. Again, the first two terms, now you notice AD being common, I'll have BD minus 4. Okay. So next, generally in factor form, as I said, if I'm able to get the same BD minus 4 yet again, so it's called factor form. But here before BD, what is there? Minus 4 is there. So this factor form trick everyone knows through 9th standard itself. So minus 4 into BD minus 4 BD. But minus 4 into minus 4 is plus 16, which is not actually present here. So what we should do, we should insert plus 16 on both sides of the equation. So now the equation becomes like this. Okay, I'm getting 2D cube plus 16 is equal to, now you can notice BD minus 4 being common, BD minus 4 times AD minus 4. Now we are successful here because people, we got an equation in factorized form and left side is just a fixed numerical value because I can start writing cases. Case 1, if you go D equal to 1, I'll get 2 into 1 cube, 2 plus 16, 18. And here it will become A minus 4 into B minus 4. You can start writing the possibilities that A minus 4 to B minus 4 becoming 18. So suppose I start with 18 into 1. So this will give me like A being 22 and B being 5. Or I can write like 9 into, so you also remember the condition. A should be greater than or equal to B according to general inequality, right? 9 into 2, if I take, A will become 13 and B will become 6. Okay. So afterwards, what you'll write? 18 into 1, 9 into 2. Then whatever you write, it will become just the reverse thing. So there A will become less than B, isn't it? So I won't be taking those cases. So now with this value of A and B, you know, you already have a relationship between C and uh, with A and B and all. So you can just get to know the values. The answer sets will be available. So I'm not elaborating those things because they are just very procedural. You can do it yourselves. So similarly, case 2, D equal to 2, you can substitute 2 cube 8, 8 is 16, 16 to 16, 32. So this will give you 2A minus 4 into 2B minus 4. So 2 is common both the places. If you bring it out, it will become 2 times A minus 2 into B minus 2. So this side you have 32. So 2 2s are 4. 8 times, 8 equal to A minus 2 into B minus 2 is what we are getting. So again, here you can take the cases of 8 into 1 or 4 into 2. So then here it will give you A equal to 10, B equal to 3, or it will give you A equal to 6, B equal to 4. The other cases will fail because A will become less than B. So similarly, you will have to go with case 3, D equal to 3. So 2 into 3 cube, 27 2s are 54, 54 plus 16, 70. 70 is equal to 3A minus 4 into 3B minus 4. So again, you can start writing the cases. Okay, I'm not gonna do that procedural work, people. I hope you got to know the most significant part of this question. 64, 64 to 128, 128 plus 16, 144 equal to 4A minus 4 into 4B minus 4. 4 is common in both the cases. You can make it out. 16 will happen. So 9 will be equal to A minus 1 into B minus 1. So find out all the integer cases and also fill in along with the value of C. Then you get which are your friendly rectangles. Hope you loved this problem. So, and again, as I insist, please put some time as your investment. Only then these ideas will start growing and become a part of yourselves. Thank you all.